In today's lesson, we're going to start with inductive reasoning and conjecture, and then we're going to start with just an introduction to logic. So our objectives for today would be to make conjectures, find counterexamples, determine truth values of negations, conjunctions, and disjunctions, and then we'll represent those using a Venn diagram. And this one we're actually going to deal with more in class. Just because it's going to be a little bit easier to deal with or to see when you're with me. So let's just start with some terms that you need to know. First being inductive reasoning. And so that's just reasoning that uses specific examples. So some kind of a very specific example to back up whatever argument it is that you have. A conjecture is just an educated guess. So it's kind of like a hypothesis, you know, like in science. It's the same kind of idea, like you're making some kind of a guess about something. And then we have what's called a counterexample. And so basically all that is just taking some kind of a conjecture and proving it to be false and saying, okay, well, this doesn't always work because this could happen. So let's start with making conjectures. So here's an example. You're a freshman in 2015. So one conjecture could be that you graduate in 2019. Another conjecture could be you are a sophomore in 2016. So I'm just making a guess based on the information here. If you're a freshman in 2015, let's say that could also mean that you are, I don't know, you could be 15 years old, you could be 14. So just making, you know, any kind of a guess. So then from there, what we do is we find counterexamples. And so for this example, the product of two numbers is positive, so the two numbers are both positive. So with this, we have more of a statement. You'll notice in this last example, we didn't have a full statement. It was kind of left open-ended, you know, kind of finish it on your own, fill in the blank. But here we have the full statement, the full argument. Well, a counterexample would be something like -2 times a -2 equals a +4. Still positive product, so it still fits the original hypothesis, but both numbers are negative. So that would be your counterexample. Okay, so that could be your counterexample. Now if I go back to our previous example and where I say you graduate in 2019, well, a counterexample would be that you graduate early. Maybe you graduate in 2019. Being a sophomore in 2016, same thing. Maybe you got ahead and maybe you're a junior in 2016. Number 3 being that you're 15. Maybe you're younger and you're only 14 as a freshman. So it's just kind of saying that, you know, it's not necessarily always right, and here's a time when it isn't. So that's all that there is to that. And so then we're moving into logic, so using the same kind of ideas, and some terms you need to know would be statement, so it's a sentence that's true or false, so just a general statement. I mean, it's very, you know, a very broad term. Truth value would mean it's either true or it's false. So if I'm asking you for the truth value of something, I'm asking you, is this a true statement or is it a false statement? Negation would mean it has the opposite meaning, and it also has the opposite truth value. So the symbol is this little thing right here. It's kind of like what goes over the N for the ñe in Spanish, if you know that, but you read it as not. So it would be not something. And then compound statement. So we have two or more statements joined by the word and or the word or. So there's two types of compound statements. So using these, we're going to talk about conjunctions versus disjunctions. So these are the two types of compound statements. So a conjunction uses the word and. It has the symbol that looks like a caret. And then for this, all parts of the statement must be true for the entire conjunction to be true. So an example would be you're learning about logic and you are in geometry. And so the way that this is generally written and shown symbolically, and actually I'm going to go ahead and write this out symbolically. So symbolically, I'm going to assign you are learning about logic. I'm going to make that the statement be represented as the letter P. And then the statement you are in geometry, I'm going to represent as the letter Q. And this is just because those are most commonly used. It doesn't have any real meaning behind it. But if I wanted to represent this statement symbolically, what we have here is P. The word and is represented by the caret symbol, and then Q. And so that's a conjunction. And so the truth value for this, so let's do truth value, is we have P, which is you are learning about logic, so that's true. And the second part is you are in geometry. Well, that's also true. And so this all together, the truth value is true. And that's all there is to the conjunctions. Now, if we had something where it was a true and false, then it would be false. So both parts have to be true. Now, when we switch over to disjunctions, we've got the word or instead. The symbol is the flipped and symbol, so this time it's more of a V. So only one part of the statement must be true for the whole disjunction to be true. So it's different because you only need one little piece. And so from here, we have the example, you are learning about angles, or you are in geometry. So again, I'm going to go ahead and assign letters. So you are learning about angles. I'm going to make that be our P statement. And then you are in geometry. I'll go ahead and make that the Q statement. So symbolically, what we have here is P, and then we have the word or, so or Q, and that's what it would look like. And then we have truth value. Well, what we have here is P, you are learning about angles. Well, that's not true right now. We're not learning about angles right now. Then we have our or, and then we have you are in geometry. Well, that's true. So since it's an or statement, only one of them needs to be true. So our truth value is that our statement is true. And that's all there is to it. And we'll work on the Venn diagrams when we get into class and practice some more of these and see how many you can come up with. So just make sure you have everything written down, and I will see you soon.